So now let's do Kepler's laws. Of planetary motion. So Kepler actually did not do all the work required to write these laws. That work was actually done by his teacher, Brahe, and he took detailed descriptions of the planet's motion, especially the motion of Mars. And based off the retrograde motion of Mars, which you have seen physically yourselves, right? Where Mars seems to go back and then it catches up. Brahe couldn't explain why the planets were doing what they were doing, but he had detailed observation from years. That's all he did. He observed the planet's motions around the sun. And from that, his student, Kepler, deduced these three laws. Law number 1. Is called the law of ellipses. (1609). That law says the orbit of each planet is an ellipse with the sun located at one of its foci. What is an equation of an ellipse? X over A plus Y over B equals 1. When A equals B, what happens to this equation? X plus Y becomes A, and that's an equation of a
Circle.
circle.
Are they supposed to be squared?
Oh yeah, they are supposed to be squared.
Yeah, nothing.
So X squared plus Y squared equals A squared. Okay, law number 2. That is called the law of conservation. Law of conservation of angular momentum. 1609. This law is also called, there's 2 names for this. Law of equal areas. This law states a line drawn between the sun and the planet sweeps out equal areas in equal times as the planet orbits the sun. Okay, number 3. Law number 3. It's called the law of harmonics. Also called harmonic law. This law says the square of the sidereal period of a planet is directly proportional to the cube of the semi-major axis of the planet orbit. This law is also called law of periods.